They're super, they're crazy, and they can be found in everything. From carpet to computers, books to boats, sneakers to the space shuttle. They're essential to mail bonding, reef repair, and cut control. Without them, our material goods would simply fall apart. Now, the stuck-up, tacky world of glue on Modern Marvels. A key breakthrough to replacing mechanical fasteners occurred in 1953. Chemist Dr. Vernon Kriebel of Hartford, Connecticut, solved the instability problem of a new adhesive that his chemist son, Robert, had brought him. Vernon Kriebel developed a cure inhibition system for a unique liquid bonding resin that hardened anaerobically, or in the absence of air.
As long as it's in contact with air, it remains a liquid. You put it onto a nut and bolt or onto a bearing or any shaft-mounted part, and what it does is it wicks its way between the threads. As soon as it's in the contact of metal and there's no oxygen for it to remain stable, it hardens to essentially a tough plastic.
The product, Loctite, solved the problem of loose nuts and bolts in machines and appliances, and is still the cornerstone of the company's adhesives business. Loctite products can be found in many of the cars on the road. But the adhesive's usefulness is most dramatic in high-performance vehicles, where vibration is intense and you can't afford to have a screw loose.
The Daytona 500, virtually every one of those cars is held together, the threaded parts especially, are held together with Loctite thread lockers.
In the 60s, part of racing was cleaning the track up, and they would literally go around the track and with a sweeper and clean up nuts and bolts that may have come off during the race. If you look at Formula One or NASCAR, these adhesives widely used are gasketing silicones, thread lockers, retaining compounds. These again are being used to be able to provide a quality race car that's not going to have loose fasteners, that's not going to have gaskets that are going to leak mid-race.
Similar considerations are just as crucial on streets and highways. During any given rush hour, there are literally tons of adhesives on the road. A car's door panels held in with an adhesive. The seats foam laminated to their coverings. The dashboard components, multiple layers with adhesive laminates. The headliner, a vacuum-formed laminated material. The rear view mirrors held on with an adhesive. Air filters, rubber trim, and gasketing contain glues. And of course, there are adhesives in the computers that increasingly run the automobile. Headlights and taillights, adhesively sealed to keep water out. Pinstriping and side molding, held on with high-performance pressure-sensitive adhesives. Even the tires are layers of adhesively bonded materials. But once you leave land and get out on the water, the demands on glues increase.
You see saltwater environments, and you've got to be able to provide an adhesive that can fill a large gap, provide structural integrity, and provide a very rigid assembly that can take impact.
Traditionally, the interior structure of a boat was made with hundreds of pieces of wood that had to be stapled together. With the help of adhesives, that process has been replaced by a composite construction into leaner, cheaper, tougher tools that continue to speed up our lives. Whether you're working on your 7th computer or your 17th cell phone, you've noticed that size matters. In the world of electronics, small is huge. One of the keys to electronic devices shrinking and becoming more convenient and versatile is the increasing use of adhesives in their manufacture. Adhesives replace cumbersome mechanical fasteners, encapsulate and protect ever-shrinking and more fragile connections, and dissipate heat on crowded circuit boards.
If you looked at the original cell phones, you look at the cell phones that we have today, one of the reasons they've gotten so small is because of adhesives. All the components that are on a circuit board that used to be mechanically held in place are now bonded with high-tech adhesives.
Computers, they're getting faster and they're getting more intuitive for the end users to work with. The customers are expecting adhesives to bond a variety of materials going from plastics, rubbers, and metals, and they're easier to use, faster curing, and can save the customer time as far as their assembly process.
Saving assembly time means saving manufacturers money. As a result, the global electronics adhesives market has grown to roughly $1 billion annually.
A lot of the adhesives that we're using are more of an insulator, such as silicones or epoxy, so they're providing some type of protection to the printed circuit board. So if it's being used potentially underwater or in a severe environment, the adhesive is acting as a protective coating.
Cyanoacrylates are also useful in the manufacture of medical equipment and small consumer devices. In a precision manufacturing setting, the glue's strength is an asset, but its instant cure can be too quick. The solution is an innovative light cure technology.
You can apply the adhesive to the surface, mate the two parts together. It will stay liquid until you shine an ultraviolet or a light on the surface. This gives the end user flexibility for manufacturing and high-quality components. Light cure adhesives, they're tailored to polymerize at a specific wavelength of light. This is an example of an LED light source, which is predominantly putting out in the 405 nanometer wavelength, which correlates to the adhesive being used.
From the minute applications in computers to the maximal amounts of adhesive pumped into boats, from the space shuttle to subflooring, without fanfare but with strength and versatility, glue holds our world together.